Uh, I welcome you all, mechanical third year students. Uh, right now, with the coming vacations due to the COVID-19, we are going to get studied by this ICT mode of interaction. Now, in this lecture, in the subsequent lecture from now onwards, we will study vapor absorption refrigeration systems and partly we will discuss the refrigerants. So, in my today's lecture, we will first discuss the vapor absorption refrigeration. Lately, thereafter, we will find the differences between the VCRS and VARS, and thereafter, by the end of this 15 minutes lecture, we will try to reach to solve the COP of ideal vapor absorption refrigeration systems. So my request to you all is that whenever you will find this video, just do keep a pen and a notebook with you all so that you can note the key points. I have in fact mentioned many things on this screen which is in front of you all. So before starting the course, I want to share with you that if you find any doubt or any problem, you can message me or mail me. Hopefully, the students of mechanical engineering section A and section B are aware of me. So let's first introduce myself. Myself Mohit Bansal, and I'm teaching you the students of mechanical engineering the course on refrigeration and air conditioning. So be attentive and follow all the lectures or the instructions of all the faculties from time to time in this period. Okay, thank you. So let's begin. So we have studied till now वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम्स. अभी आप लोगों ने जब वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम्स पढ़े तो उसमें हम क्लास में एक बात डिस्कस किया करते कि वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम की सबसे बड़ी खासियत ये बात है कि the working fluid undergoes the phase change, which we have seen in the evaporator and in the condenser. In the evaporator, the wet refrigerant extracts the heat from the refrigerating or the evaporator part and converts itself into the saturated vapor. Thereafter, it is compressed in a mechanical compressor, and later on, when it passes through the condenser or the condensing medium, it changes again its phase from superheated vapor to the saturated liquid. So likewise, vapor absorption refrigeration systems falls under the category of vapor cycles. So the main जो समझने का बात है वेपर साइकिल्स में कहीं भी, that in these cycles the working fluid must or should undergoes the phase change during its operation. Here also, when we study the vapor absorption refrigeration system, the refrigerant, you will see the refrigerant or the refrigerant vapor will change its phase during its course of action. So this may be treated as a similarity between the VCRS, vapor compression refrigeration system, and the vapor absorption refrigeration systems. However, the major difference in vapor absorption refrigeration system is that the vapor absorption refrigeration systems uses the low grade thermal energy, and that's why they are also called as heat operated systems. Now, what is this low grade thermal energy? Actually, we have seen in the vapor compression refrigeration system, after the evaporator, the saturated vapor enters inside a compressor where it is compressed to the condenser pressure. So that compressor is basically a mechanical device, and that compressor requires mechanical energy to run itself. So the mechanical energy is some sort of high grade energy. Now, the major difference in the vapor compression and vapor absorption is that we will replace the mechanical energy system to a thermal energy system, and thermal energy we will treat it as a low grade energy. That's why sometimes the vapor absorption systems are also called as heat operated systems, whereas the vapor compression refrigeration systems are also known as work operated systems. This may be treated as a difference. And second, yes, this second difference is that you have seen in vapor compression refrigeration systems, we have used some artificial refrigerants like R134A, R1, R11, R12, R22. These all refrigerants are artificial refrigerants, or these are made in laboratory. Whereas the thing which for the refrigerants used in vapor absorption, we will see during these lectures that the refrigerants which are used in vapor absorption refrigeration systems, they are natural, like water, H2O, and ammonia, NH3. They all are environment friendly as compared to vapor compression refrigeration systems. So this is again an advantage of vapor absorption systems, and is also a difference between VCRS and VARS. We generally call vapor compression as VCRS and vapor absorption as VARS. Now moving further, the basic concepts of VARS. The basic concept, I'm going to read this and further we will learn this. What is this? In a VARS, when a solute, example like lithium bromide, is dissolved in a solvent like water, the boiling point of the solution is elevated. The other thing is, if the temperature of the solution is held constant, then the effect of dissolving the solute is to reduce the vapor pressure of the solvent below that of its saturation pressure at that temperature. Okay, now what does it mean? So we will learn this thing with the help of an experiment. So the experiment is something like, we have two flasks or two reservoirs, reservoir A and reservoir B. Reservoir A is filled with water, and at 30 degrees Celsius, and reservoir B contains a mixture of water and lithium bromide. In this system, water is a refrigerant and lithium bromide is an absorber. We will study that what is an absorber, but till now, as name suggests, absorber is a fluid which absorbs the refrigerant. So in this flask B or reservoir B, 50% of lithium bromide is there by mass at 30 degrees Celsius. And we may take this 30 degrees Celsius is the ambient temperature in which this complete experiment is conducted. So these two containers are connected with these two pipes and they are joined with the help of a valve. In the initial case, in equilibrium conditions, these two reservoirs are connected with the valve, but this valve is closed. So there is no interaction of the fluids of reservoir A with the reservoir B. Now, if we see the pressure of water at 30 degrees Celsius from steam table, so this is the steam table, saturated water and steam. So just see the saturation pressure, the pressure which the water contains at 30 degrees Celsius. So I just want to give your emphasis on this, like this is saturation pressure at the specific temperature. So when we say water boils at 100 degrees Celsius, then across that 100 degrees Celsius the saturation pressure is somewhat 1 bar or 0.1 megapascal. So likewise, if in the reservoir A we have the temperature as 30 degree, so across that 30 degree we have a saturation pressure of 0.00424 megapascal, or we may call it as 4.24 kilopascal. It is megapascal, multiply with 1000, it becomes 4.24 kilopascal at 30 degrees Celsius. So the water is at a pressure of 4.24 kilopascal at this saturation temperature. Now in the reservoir B, which contains a solution of water and lithium bromide at 30 degrees Celsius, so we have a table also which is given by Paris. So in that table we can find the saturation pressure of this mixture, which is of 50% lithium bromide along with water at 30 degrees Celsius. It contains a vapor pressure of 1.22 kilopascal at this condition, 30 degrees Celsius, of this mixture. So in the second case, what happens when the valve, in the first case the valve was closed. Now when the valve was opened, what we have seen, when the valve is opened, as here it was 4.24 kilopascal and it was 1.22 kilopascal. So water vapors moves from high pressure to low pressure, and the movement of water vapor start from this pipe to this section, from reservoir A to reservoir B, until the pressure of both the reservoirs becomes equal, that is 1.22 kilopascal. Water vapor starts to move